All right, let's dive into one of the most famous and, let's be honest, one of the most mind-bending ideas in all of science, Schrödinger's cat. It's a concept that really makes you wonder if reality is as solid as it seems.
But before we get to the cat, let me ask you something. What if the simple act of looking at something changed it? I don't mean in some philosophical way. I mean, what if your observation literally forced it to become what it is? That's the strange and incredible world we're about to step into.
At the heart of all this is a famous imaginary cat. This cat is sealed inside a box, and according to the wacky rules of quantum mechanics, it's stuck in a state that seems absolutely impossible. It's somehow both alive and dead, all at once.
So let's talk about this famous cat. Now, this whole idea was dreamed up by the brilliant physicist Erwin Schrödinger. And it is super important to remember, no actual cats were ever involved. This was purely a thought experiment, a tool he created to explore a really weird idea at the very edge of physics.
You see, Schrödinger wasn't trying to prove that a cat could be a zombie. Not at all. His whole point was to show just how absurd things get when you take the rules that apply to tiny, subatomic particles and try to scale them up to big, everyday things, like, well, a cat. He wanted to shine a giant spotlight on a paradox.
Okay, so to really get what Schrödinger was talking about, we have to understand the bizarre rules of the quantum world itself. And trust me, these rules operate on a totally different logic than anything we're used to in our daily lives.
I mean, think about it. In our world, things are definite, right? A light switch is either on or it's off. There's no in between. But down in the quantum world, things get fuzzy. A tiny particle, like an electron, can actually be in multiple states at the exact same time. It can be both on and off at once.
This mind-blowing concept has a name, superposition. A great way to think about it is like a spinning coin. While it's up in the air, spinning around, is it heads or tails? In a way, it's both, right? It only becomes one or the other when it finally lands and we look. Superposition is just the quantum version of that spinning coin. The particle exists in a cloud of all its possibilities at the same time.
And this is exactly what Schrödinger was getting at. He was asking, okay, where does this weirdness stop? If a teeny tiny atom can be in two states at once, what happens when we link its destiny to something big, something we can actually see and touch? This whole experiment is designed to expose that strange, blurry line between the quantum world and our world.
Now here's the second crucial rule, the observer effect. The moment you measure a quantum system, that fuzzy state of all possibilities, that superposition, it instantly collapses into just one single definite outcome. Think about your phone's GPS. Your phone could be anywhere in a general area, but the second you open a map app and it asks, "Where are you?" that cloud of possibilities collapses to one single dot on the map. The request, the observation, forces a decision.
Okay, so we've got our two rules, superposition and the observer effect. Now, let's put on our lab coats and build Schrödinger's famous box. Let's see how these rules come together to create this impossible alive and dead cat.
Let's walk through the setup. First, inside our sealed box, we have a single radioactive atom. Because it's a quantum object, it's in a superposition of both decayed and not decayed at the same time. Next, we rig up a Geiger counter that will only click if that atom decays. Then, we connect that click to a hammer, which is positioned right over a small vial of poison. And finally, inside the box, we have our cat. You can see how this works, right? The cat's fate is now completely tangled up with the quantum state of that single, tiny atom.
And this is where it gets absolutely wild. If the atom is both decayed and not decayed, and the hammer is both fallen and not fallen, and the poison is both released and not released, well then the cat must inherit that same quantum fuzziness. Until we look, the cat is in a superposition of being both alive and dead.
So there it is, the paradox. Our common sense is screaming that a cat can't be both alive and dead. So what happens when we finally step in? What happens when we open the box and become the observer?
So before we lift that lid, all we can really do is talk about probabilities. There's a 50% chance the atom decayed and the cat is dead. And there's a 50% chance the atom hasn't decayed and the cat is alive. The system holds both of these possibilities at the same time, in equal measure.
But the simple act of opening the box, of looking inside, that's the game changer. Just like checking the spinning coin, our observation is going to force this entire chain of events, from the atom all the way up to the cat, out of its fuzzy superposition.
Reality has to pick a side.
So we open the box. In this reality, the wave function collapses, and the cat is alive. Whew! Now it could have just as easily gone the other way. The key isn't which result we get. The mind-blowing part is that until that exact moment of observation, both results were in some sense true. Reality was waiting for us to make it choose.
And that's the truly profound idea here. And it's so much bigger than just a cat. It suggests that maybe reality at its very core isn't fixed. It's more like a choose-your-own-adventure book, where all the storylines are happening at once, and it's our interaction, our observation, that picks the one path that becomes our reality.
But hey, this isn't just some dusty philosophical puzzle. These completely bizarre quantum rules are being used right now, today, to build the technology of the future.
I mean, quantum computers use this superposition idea to explore millions of solutions to a problem all at the same time. And quantum cryptography? It uses the observer effect to create perfectly secure communication. Why? Because if anyone tries to eavesdrop, their very act of observing the data changes it, and you know instantly that someone is listening in. It's amazing.
To give you a sense of the sheer power we're talking about here, a few years ago, a quantum computer solved a particular problem in 200 seconds. Want to guess how long it would have taken the world's most powerful supercomputer at the time? 10,000 years. That's the power of putting superposition to work.
So we end right back where we started, with a huge question. Schrödinger's cat forces us to look at the very nature of reality. Is the world out there a fixed, solid thing that just exists, whether we're looking or not? Or is it more like a shimmering ocean of possibilities, a reality that we, the observers, actually play a part in creating every single moment we look at it? The cat is out of the box. What you decide? Well, that's up to you.